Good afternoon. I'm Andrew Samples, the Southeast Rep for SQM. We really appreciate y'all joining us. I want to thank the Georgia Citrus Association for the opportunity to put this course on, and we really hope you take away a lot from it. We're going to go ahead and get started while people are still joining in. All right, with that, we'll go ahead and get started. I'll hand it off here to JW. He is our agronomist here in the U.S., and we can get things going.
Thanks, Andrew. Welcome, everybody. I hope you get something out of this. We put some good time in it. We got good people working on it. One of our things is to share education, show what we've done in research. I'm the national agronomist. I've had a lot of varied experience from coast to coast, and right now I handle all the United States and Canada. But when I have a question, I take it one step further and I go to the experts. I'd like to introduce him in just a moment, but first, just so you people have an idea, you can glance at this slide. You know what we're going to be covering: our resources, efficient mineral plant nutrition concepts, differences between K sources, differences between in-source benefits and K foliar treatment. We'll move on to our resources just quickly. Out of the Atacama Desert in Chile, that's where the caliche ore is. And we get high concentrations of nitrate and iodine out of that in a long, lengthy process. We also have the salt flats. They're 25% of the lithium for the world. The reserves are all there. Large amounts of potassium salts as well. So you can see we're all about potassium nitrate. This is your starting slide, and I would like to introduce Felipe. He is one of our world agronomists. He's the person that I go to for answers. So Felipe, with all your experience of traveling around the world and countries, welcome, and it's your turn. Take away.
Well, thank you, JW. Thank you. Well, thank you all of you to be present. It's a great pleasure to me have the opportunity to exchange some knowledge with all of you about how to be efficient in mineral plant nutrition, and on this case, especially with citrus. From the nutritional management point of view, how can we help the plant in increase yield or increase quality, that at the end this will result in increased profitability to the farmers? If you think as a farmer, what we want as a farmer, we want to produce more and with more quality, and then with this we can reach better profitability. So then if you're thinking in the nutritional management point of view, how can we do that? Now, the way that you can do that is being efficient with the minerals that we apply. When you're thinking in mineral nutrition or in plant nutritional, we are applying minerals to the soil or in the nutrient solution to feed the plants. So how can we do that? We need to think in the balance of the minerals that we will have in our soil, because plants does not recognize products, commercial products. Plants recognize chemical elements: nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, boron, zinc, all the macro and micro nutrients. That is what the plants recognize. So if we want to be efficient in plant nutrition to help the plant in produce more and produce with more quality, we need to think, okay, what is the chemical balance that I'm applying or supplying to my plant? And this is what this presentation is about. It's how to be efficient with the minerals, with the chemical elements, or with the sources that we are using to feed our plants. And now with this concept, to be efficient with plant nutrition, basically we need to answer 4 questions. So the key point is, okay, we need to know what we need, and to know what we need is according to the crop that we are talking about. On this case today, the focus is in citrus crops. So then what we need to answer, the first question is, That's the basically the 4R concepts. When I will apply, and that's according to the phenological stage of the crop, on this case citrus, where I will apply, what dosage I will apply, and the most important thing with this concept, what source I will apply. Because the source that I will apply will define the minerals or the chemical elements that will be present in the soil nutrient solution for the plant uptake. So let's go through one by one these key points to be efficient with mineral nutrition in citrus. When to apply? Well, when it's according to the phenological stage. To be efficient, we need to first of all know the phenological stages of the plant. Now we are in pre-bloom, full bloom, post-bloom, during fruit growth development. Now, in all these phenological stages, plants need minerals, but the balance between these minerals is different according to the phenological stage. So we needed to think in what is the phenological stage that my plant is now, and then apply the nutrients according or in the right balance to that specific phenological stage. So know the phenological stage is very important to be efficient with plant nutrition. Now, the second point is where I apply. Well, the basic answer for this question is we need to apply the minerals, the nutrients, where the roots are. And this is different according to the system. For example, if you work with fertigation, normally the roots are on the wet bulb when we have the humidity. So that's, let's say, it's quite simple, because if I use fertigation, automatically the nutrients will go together with the irrigation water, and then will be present on the root zone. The only remark here is that we need to be sure that the irrigation management is being doing well done, because if we over irrigate it, for example, then we can lose some nutrients by leaching. But if the irrigation management it's well done, so that it's automatically the fertilizer will go together with water for the root zone. But when we don't have when we don't have irrigation system, or in areas that are not irrigated, so then normally we need to apply the nutrients or concentrate the nutrients in the place where we have the most number of active roots. And normally the place where we have the highest number of active roots, it's on that green part that we can see between the red and green lines at the border of the canopy. So normally on the third part at the border of the canopy, that's the place where we have most concentration of the active roots. And that will be the place where we need to concentrate our fertilizer application in areas that are not irrigated. Because with most active roots, then the uptake will be higher for the plant. Another point to consider to define the dosage, what dosage I will apply, that it's according to the nutrient extraction, and it's different for any crop. Any crop have his own nutrient extraction. On this case, we are talking about citrus, and then we will see that according to citrus type, we have different nutrient extractions considering the amount of nitrogen, phosphorus, potassium, magnesium, calcium for all the nutrients in pounds per metric ton of fresh fruit. So if you look to this, we will see that according to citrus type, we have different nutrient extraction per metric ton of fresh fruit produced. But we will see that for all of them, we have something in common, that for all the citrus types, always potassium is the nutrient most required, and nitrogen is the second one. And then we have all the others. But if you look at the amount of potassium and nitrogen, that are the two nutrients that the plant needs in higher amounts. But all the others the plant needs as well, and have the same relevance, the same importance. But just the amount of nitrogen and potassium is higher. So this data together with the expected yield, give to us an idea about how much nutrients I need to apply. And that's define the dosage. Because if I have my expected yield and I have my nutrient extraction, okay, then more or less I know how much nutrients or how much minerals I needed to replace in my soil. And as I say, you see that on the case of citrus, potassium and nitrogen are the nutrients required in highest amounts. And that gives to us a very important point to do this management, that is the nitrogen-potassium ratio. That's a physiological concept that works for all the vegetables, not for any crop, not only for citrus. It's a physiological concept. The nitrogen-potassium ratio change according to phenological stage, and then we can do the management or interfere in the behavior of the plant doing the management of the nitrogen-potassium ratio. Because when we apply more nitrogen, at the end inside the plant, more nitrogen means more production of amino acids, proteins. And then this is a kind of vegetative signal to the plant. So more nitrogen, more amino acids, more proteins, more vegetative growth. When we apply more potassium, potassium is more carbohydrates transport, maturation, sugars conversion, color, all these things, more for the generative stage. So if I apply more potassium in comparison with nitrogen, I can do the management and guide to the plant more to generative stage, and with more nitrogen, more for a vegetative stage. So according to the balance between nitrogen and potassium, we can interfere as agronomists or as growers on the vegetative growth of the plant, in filling the reserve organs of the plants, then fruits in case of citrus, but tubers in case of potatoes, bulbs in case of onions, for any crop. It's a physiological concept. We can do this management. The development of the reproductive organs, translocation of photoassimilates. When we increase potassium in comparison with nitrogen, we are increase the translocation of photoassimilates, sugars, increase fruit size, fruit coloring, bricks as well, especially for that produce orange for industry, for juice. So then it's something really important. And the maturation and post-harvest fruit quality. So then with this balance between nitrogen and potassium, we can interfere in all these physiological concepts, and we can do that according to the balance of these minerals that we apply together with our fertilizers. So the nitrogen-potassium ratio, according to the phenological stage, we can follow more or less that simple rule. For the vegetative stage, a ratio between 1:1 nitrogen, potassium. That means same amount that you apply as nitrogen, I apply the same amount as potassium, 1:1. That it's a vegetative ratio. When you have the flowering moment or pre-bloom, pre-flowering, then it's good to switch to, for every, let's say, 1 pound of nitrogen applied, 1.5 pounds of potassium applied. That it's a more neutral ratio. And this is also help the plants in get a better fruit set, fruit retention. And for the generative stage, that we call generative stage after flowering, when you are developing the fruits, filling the fruit that you want to increase the size of the fruits and so on. So that's a 1:2 ratio. For every pound of nitrogen, 2 pounds of potassium. That's the generative ratio between nitrogen and potassium. And then we have a bigger fruit size, coloring, bricks, sugars, all these things. So that it's a general concept of mineral nutrition that we can pay attention and check according to the phenological stage if I am applying the right balance between the minerals. On this case, between nitrogen and potassium, that as we saw is the nutrients that are required in the highest amount by the citrus crop. So when you think the last point that I mentioned, that is for me is the most important point, it's what source I will apply. So when we think in the source that we apply, it's about the minerals that we apply. So if taking in potassium, that is the nutrient most required by citrus crop that we need to apply, followed by nitrogen. What sources of potassium, as example, I can use to feed my plant? Us as company, as fertilizer company, we produce the 3 potassium sources. We produce potassium nitrate, potassium sulfate, and potassium chloride. So we are a producer of the 3 potassium sources. From the agronomical point of view, what is the difference if I want to be efficient and increase yield and quality? Which one of these 3 sources should I use to be efficient with my plant? And this is what I would like to discuss with you now. We can compare, for example, if I take the example, potassium nitrate. Let's say potassium nitrate, you apply 13% nitrogen, 45, 46% potassium. We can reach this same balance if I do a mix with potassium sulfate, with some urea or ammonium sulfate or any other source of nitrogen. Then if I mix potassium sulfate with some nitrogen source, I can have the same balance or apply the same amount of nutrients if I'm using potassium nitrate, for example. But the result for the plant will be the same. The amount of nutrients applied will be the same. But from the chemical point of view for the plant, the result will be the same. This is what we will discuss now on this presentation. When I say that the source that you use to apply the minerals are very important, it's because we don't need to think to be efficient in plant nutrition. We don't need to think in products, what product are you applying. We need to think, okay, which chemical elements, which minerals are you applying my balance? And that's really the difference when we compare the fertilizer sources. For example, let's compare the potassium sources, as potassium is the nutrient most required by citrus crop. If you look to the potassium sources, we will see that from the chemical point of view, it's no difference, because in all potassium sources, the potassium is present and expressed as K2O, potassium oxide. So let's say potassium is in the same chemical form. So that's no difference for the potassium. But the real difference between the potassium sources, it's about the counterion, the element that comes together with potassium. Example, if I use potassium nitrate as source, together with potassium, I am applying nitrogen. If I use potassium sulfate or thiosulfate, we are applying sulfur together with potassium. And if you use muriate of potash, potassium chloride, together with potassium, we are applying chloride. And that's the real difference. So, for example, comparing the potassium sources, the difference is not about the element potassium itself, but it's about the counterion, the element that will come together with potassium. And you need to consider that because that element will be present in our soil solution. So let's do a comparison between all the sources one by one. Let's start it with the KCl, potassium chloride. We need to consider the sensitive of the crop that we work to chloride. If it's a chloride sensitive crop, so then you need to think, okay, we need to avoid use potassium chloride. And most part of the crops are sensitive to chloride, especially if you go to crops like lettuce, strawberry, flowers. Now, these are avocados. These are crops that are really sensitive to chloride. Potato, more or less. Citrus as well have a moderated sensibility to chloride. So that means that you need to pay attention. If I use only potassium chloride as my unique and exclusively potassium source for citrus, keep in mind and do the calculation the amount of chloride that you are applying as well in your nutrient solution, because that chloride will be present there. And the problem with the excess of chloride is the toxicity, because plants use the element chloride as a nutrient, but as a micronutrient, use it in a really small amounts. And when we are applying or supplying chloride in kilograms, in higher amounts per acre, then we start to see that symptoms on the leaves, the border of the leaves. You can see that that symptoms of chlorosis on the border of the leaves. That's toxicity by chloride excess. As you can see in different crops as well. In citrus, it's quite common. In banana as well, it's a crop that's very common. And you need to keep in mind that the negative effect of that is that we are reducing the area of the leaves that are doing photosynthesis. So we are reducing our photoassimilated production, because that areas that are burned with that symptom are not doing photosynthesis anymore. And that is the negative effect that impact in our yield or quality when you have that symptoms of chloride toxicity in our plants. Another point to consider, it's about the soil, not only about the plants, but we need to consider as well the amount of the chloride that will remain in soil, especially in soils that contains higher amounts of clay, because then the leaching effect, it's lower. If it's really pure sandy soils, then okay, we can leach it out some chloride and decrease the effect. But especially when we have soils with higher clay content, so then you need to consider as well the increase on the salinity or on the electrical conductivity in the soil. That will bring as well a negative effect, that as higher is the EC, electrical conductivity, as higher is the EC, higher is the spend of energy to the plant uptake water and nutrients from the soil. And we don't want that plants spend energy to uptake water and nutrients from the soil. Plant need to save energy to producing fruits, filling the fruits with good size, good color, good bricks, and so on. Now we need to save that energy, that carbohydrates to that, and not to the plant just uptake water from the soil. If you look to the potassium, the sulfate of potash as source, that is an excellent source, but you need to keep in mind the balance between the sulfur, because together with potassium, we are applying sulfur when you use only potassium sulfate as our potassium source. And then we need to consider the nutrient extraction of the crop. If you take the highest numbers, average, for example, for orange nutrient export, and consider for every metric ton of fresh fruit, we need to around 7 pounds per metric ton of potassium and around 0.3 pounds of sulfur. So that is the balance according to the nutrient extraction. That gives to us a ratio for every 1 pound of potassium, I need 0.04 pounds of sulfur. So that's the balance that the crop need. If we use only sulfate of potash as potassium source, that the composition of sulfate of potash is 50% potassium and minimum 17% sulfur, this gives to us a ratio for every pound of potassium, 0.34 pounds of sulfur. That represents 8 times more sulfur than the crop need. And if you use potassium thiosulfate, that contains more sulfur than sulfate of potash, then we are applying 70 times more sulfur than the crop needs. And then we start to have the excess of sulfur. So we can use sulfate of potash or potassium thiosulfate, but we need to pay attention on the sulfur demand of the crop in order to avoid the excess of sulfur. Now, sulfur is an essential element as well. We need to apply it, but as any other element, we need to avoid the excess. The excess of any mineral, any nutrient, will bring some negative effect. Excess of potassium is not good as well, excess of nitrogen, excess of phosphorus, no matter the nutrient. Any nutrient that is in excess will create or generate an imbalance with the other minerals. And this is what we want to avoid. So we need to consider what is the sulfur demand of the crop that I will work. And then we can use sulfate of potash as potassium source till we reach the sulfur demand of our crop. So then you need to change or switch for another potassium source in order to avoid the excess of sulfur. Because the excess of sulfur can bring mainly two negative effects. First, it's a kind of soil salinity buildup, because any mineral in excess that remain in soil will increase the EC, the electrical conductivity. So if I am applying sulfur in excess, plant will uptake the amount of sulfur that the plant need, the excess will remain in soil, and then I start to accumulate salts, minerals in soil and start to increase the EC. And with this effect, if really we increase the amount of sulfur in higher levels, I can also start to lose some calcium present in my soil, doing the calcium fixation, doing the gypsum formation. When calcium meets with sulfur in solution, then you have gypsum formation. It's the same principle in the reason because we cannot, for that ones that work with fertigation, we cannot mix, for example, calcium nitrate with potassium, with sulfate of potash in the same fertigation tank, because then you see at the bottom of the tank, the gypsum precipitation. So if we have this in higher concentrations in soil solution, we can lose some calcium and some sulfur as well, due to gypsum formation in soil. That's the main effects that we need to avoid when we are thinking and be efficient in our fertilization scheme. Another point to consider, as I mentioned, is the compatibility between the sources. And if you use, for example, potassium nitrate, it's fully compatible with fertilizer and most of agrochemicals. And with sulfate of potash, we need to take care and be sure that we will not be present together with some calcium source in the same solution, because then we will have gypsum formation, as you can see on the picture. This is a video. I would like to show to you a video that was produced for our team in the United States that show exactly the effect when you do in soil, a comparison on the solubility between potassium and between sulfate of potash and potassium nitrate. So they prepared a video when the soil was kept, the moisture was kept humid during all the trial, and you can see the effect on the dissolution. And why the effect on the dissolution is important? It's because as faster the fertilizers is dissolved, that means that faster the nutrient will be available for plant uptake. So when we see difference on the solubility between the sources that we are using, we need to keep in mind that that difference will be reflected on the nutrient availability for the plant uptake. So as faster the fertilizer is dissolved, faster the nutrient will be available for plant uptake. And that's very important, especially if we're thinking in areas when that are not under fertigation. For the areas that it's under fertigation, that's not relevant. But for the areas that are not irrigated and we apply prius or granular fertilizers in the field, for that areas, that difference on solubility, that's really relevant and important, and you need to consider that. Now, I think that we have a kind of problem with the video, with our webinar jam system, but I will continue with the presentation, and then as soon as they solve the problem, then we will show the video to all of you. Another effect, when you do this comparison, it's about the EC, as I mentioned, the electrical conductivity on the soil solution. When we apply, for example, 1 gram, when we dissolve 1 gram of sulfate of potash, potassium sulfate, in 1 liter of water, we will reach the EC of 1.54. If we dissolve the same gram in 1 liter of water of potassium nitrate as source, the EC is 1.35. So we see that the EC is a little bit lower. What this means in practical for the plant? For the plant, that EC, it's salt concentration in a solution. That means that the salt concentration, it's lower when you use potassium nitrate. That means that plants spend less energy to uptake water and nutrients from the soil. And when the plants spend less energy to uptake that water, that means that plants have an extra energy to developing fruits, to grow to the leaves, or to do what the plants need to do on that moment. So when we increase EC, it's the same that you are saying you are increasing salinity. So as lower is the EC, lower the salinity, better for plant uptake water and nutrients from the soil. So as lower is the EC, that's better for the plant to be efficient in water and nutrients uptake. An example of this, if you take the electrical conductivity, the EC of straight potassium nitrate as a standard. So let's consider 100% or 100 as the standard of the EC of potassium nitrate, with potassium nitrate supply 13.30% of nitrogen, 46% of potassium. If you do that same mix to supply 13 units of nitrogen and 46 of potassium, doing a blend between sulfate of potash and ammonium nitrate, for example, the amount of nutrients that we apply will be the same, but the increase on EC will be 46% higher. So the amount of nutrient is the same, but the increase on the EC, on salinity, it's 46% higher. If we do that blend between sulfate of potash and ammonium sulfate to supply the same amount of nutrients as potassium nitrate, the increase on EC, it's almost the double, 92% higher in increase in EC for the same amount of nutrients supplied. That is be efficient with mineral nutrition. It supply the same amount of nutrients with the lower increase of the EC or salinity in our soil. This is the way how can we help the plants in be efficient as well, in do what the plants do. Photosynthesis, producing sugars, fruits, carbohydrates, and then give to us highest yield with highest quality. Now, this is a practical example about how the sources that we decide to use it interfere in our balance in soil solution. Now, this is a real example used in the Netherlands in the greenhouses. So that means hydroponic system, but it's a similar concept in the nutrient solution when the fertilizers are dissolved and the minerals are present in nutrient solution in soil is the same concept. Now, just to exemplify to you the effect of the source that we decided to use it on the balance in the minerals in soil. So these numbers are all milligrams per liter, as you can see. So if you look to the right, let's start from the right to the left with sulfur. Now we see that we needed to supply 71 milligrams per liter of sulfur in the nutrient solution for tomatoes, sweet pepper, and cucumbers in the Dutch greenhouses. This 71 milligrams per liter is composed by 53 milligrams came from magnesium sulfate, because magnesium sulfate is the magnesium source of the nutrient solution. And then when they supply the magnesium, together with magnesium sulfate, they are supplying as well 53 milligrams per liter of sulfur. And then they complement because they need 71. So 53 comes from magnesium sulfate. So they complement the other 18 milligrams per liter that they need with sulfate of potash. And then they reach the 71 milligrams per liter. That is the target of the nutrient solution. And with this, we reach sulfur, and then we can move for potassium. When we supply that 18 milligrams per liter of sulfur using sulfate of potash, we are supplying as well 44 milligrams per liter of potassium. And they use MKP, monopotassium phosphate, as phosphorus source in the nutrient solution, and supplying the amount of phosphorus that they need for the nutrient solution using NKP, they are supplying as well 51 milligrams per liter of potassium, but they need 314 milligrams per liter. And then on this case, they use potassium nitrate to supply the other 219 milligrams per liter of potassium. And then they reach the target, 340. When they use potassium nitrate as source to supply the amount of potassium that they need, potassium nitrate, they apply as well nitrate nitrogen, 71 milligrams per liter, and the rest to reach 224 milligrams per liter comes from calcium nitrate. That is the calcium source of the nutrient solution, as calcium nitrate as well contains around 1% of ammoniacal nitrogen. Then they supply as well 16 units of ammoniacal nitrogen. That gives to us a balance from our total nitrogen applied in the nutrient solution. 93% of the nitrogen is in nitrate form, and 7% of the nitrogen, total nitrogen, is ammoniacal form. So this is the balance, the real balance of the nutrient solution. Now, what's happened if we just change the source? Let's not use potassium nitrate, and let's use only sulfate of potash to apply all the potassium that we need. What's happened is, first, let's start from the left to the right, from the right to the left again with sulfur. We increase from 71 milligrams per liter before, now 161 milligrams per liter. So that's the point when you start to have problems with excess of sulfur. Now, if we replace the potassium nitrate from the potassium sulfate, sulfate of potash, first effect in the balance of the nutrient solution, you see an increase on an excess of sulfur. As we see, we increase from 71 to 161. Potassium, nothing changed because we keep the same 314 units. But when we remove potassium nitrate, we remove as well the nitrate nitrogen that we are applying. Remember that we apply 79 units of nitrate nitrogen when you use potassium nitrate as source. Now we needed to apply that 79 units with other nitrogen source. That normally is not a nitrate nitrogen source, because the farmer already apply all the calcium that they need in the nutrient solution, so they can't apply more calcium nitrate because the calcium is already on the desired level. So then they use ammonium sulfate or any other nitrogen source, but normally it's ammoniacal nitrogen, not nitrate. And then we have the second difference, that we change the balance between nitrate nitrogen and ammoniacal nitrogen. Now we have a balance that it's 58 nitrate and 42 ammonium. And before it was 93 nitrate and 7 ammonium. And then we start to have problems like blossom end root, for example. In problems, you start to have problems with, for example, calcium uptake. So that's the problem when you start to change the source, or thinking in the source that we are using. This is the effect or impact on the balance in the minerals on the soil nutrient solution. And it's about this that you need to think on it. It's not about with what product I will apply. No, with the product that I will apply, what will be the balance between the mineral nutrients in my soil solution? And then you really will be efficient with mineral nutrition. So let's move to the nitrogen source. As I mentioned to you, the balance between nitrate and ammonium. So what is the balance between nitrate and ammonium? So what's the difference? When you think in a nitrogen source, we need to think in some points, like sensitive to the plant of ammonium nutrition, temperature range at the root zone, presence of saline growing conditions, water use efficiency. So let's go one by one these points, because the balance between ammonium and nitrate have different or have an impact in all these points. Now let's start with this sensitive to the plant to the ammonium nutrition. When we're using the source, when we choose the source that we use, remember that if you choose as potassium source, use potassium nitrate, together with potassium nitrate, we are applying nitrate nitrogen. If you use potassium sulfate, thiosulfate, or potassium chloride, normally the nitrogen source that you use together with this potassium source, urea, UAN, ammonium sulfate, are ammoniacal nitrogen. And this is the difference, because if you look to the symbol, nitrate have a negative charge. It's NO3 minus. Ammonium have a positive charge, NH4 plus. And from the chemical point of view, that's made all the difference, because elements with negative charges, nitrate, are anions, and elements with positive charge as ammonium are cations. And then doing the chemical balance, synergism and antagonism between the elements, that's made all the difference. Yeah. Another point to consider, it's about the effect on the pH effects. When you have ammonium, we have an acidification effect on the rhizosphere. And when you have nitrates, we have the pH stable on the rhizosphere. Now, if you look to this photo, is a scientific study conducted when you keep half of the root system fed with ammonium, and then the other half of the root system fed with nitrate. Same amount of nitrogen applied in both sides, but one 100% in ammoniacal form, and another one 100% in nitrate form. And we can clearly see in the picture that on the rhizosphere, on the soil that was fed with ammonium, that the pH it's below 4.5, as you can see here on the scale. And on the rhizosphere, in the soil that was fed with nitrate, the pH is around 6. And that is the effect on the pH. So if you are growing some crop under alkaline conditions, that's okay. You have a beneficial effect and have some ammonium. But if you are growing crops in an area that have a pH already stable, neutral, or especially if in acid conditions, so then you really need to avoid use ammoniacal nitrogen and use nitrate nitrogen. Another point, and that's another difference between cations and anions with the charges. We start with the antagonism and synergies. It's because nitrate have a negative charge. Chloride have a negative charge as well. So that means that these chemical elements have the same charge. That means plant cannot uptake both together. Plants, to keep the chemical balance, always need to apply in balance cations and anions, and then they keep the balance. So that means if plant is uptaking nitrate nitrogen with negative charge, plant cannot uptake chloride as well. Even if the chloride is present in the soil solution, the chloride is there, but the plant will not uptake chloride if the plant is uptaking nitrogen in nitrate form, because they have the antagonistic effect. They are antagonic because both have the same charge. With ammonium is the opposite. If you are growing crops in saline conditions, and that saline conditions is caused by chloride, and you apply ammoniacal nitrogen have a positive charge. It's a cation. If the plant uptake nitrogen in ammoniacal form cation, plant will need uptake an anion to keep the balance, and then on that case, plant can uptake chloride together with ammoniacal nitrogen. So we need to keep, especially under saline conditions, it's much better to have nitrate nitrogen than ammoniacal nitrogen. And for the same concept and the same reason, For the uptake of nutrients, that's antagonism and synergism. We see that on this animation. When the plant is uptaking ammonium, ammoniacal nitrogen, plant cannot uptake at the same time, for example, calcium, magnesium, and potassium. Because calcium, magnesium, and potassium are cations, are plus, with plus charge. That's the same charge as ammonium. So ammonium, calcium, magnesium, potassium, zinc, all these elements have positive charge. So plant cannot uptake these elements together. And with nitrate is the opposite, because nitrate is an anion with negative charge, and always when the plant uptake nitrogen, nitrogen, plant can uptake together with the nitrogen, magnesium, potassium, or calcium to keep the balance, because then the plant is uptaking one element in a negative form and another element in a positive form. So as we saw, potassium is the element most required by the citrus crop. So if we want to improve the uptake of potassium, we need to increase the amount of nitrate nitrogen in our soil solution, because together with nitrate nitrogen, plant will uptake other cations. If I apply ammonium, together with ammonium, positive charge, plant will not uptake potassium, calcium, or magnesium. So that is about the antagonism and synergism in the elements. Elements with different charges have synergies. The synergies between positives and negatives. They walk together. Antagonism means elements with the same charge. Both elements with the same is a kind of the same principle of a magnet. You cannot put together the both sides of a magnet with the same positive charge. There needs to be one positive, one negative. So then you can put together the magnet. That's the same chemical principle here. And this is the effect in plants. About this concept that I showed to you. This is the practical effect. This is a graphic that show in watermelon, but it's a physiological concept that work for all the crops, and the effect on this. If you look to this graphic, at the bottom, you have the nitrate and ammonium ratio. When you have that numbers 3:1, 3:1 means from the total nitrogen, 75% was in nitrate form and 25% in ammoniacal form. Then 1:1, 50% nitrate, 50% ammonium, and 1:3, the opposite, 25% nitrate and 75% ammonium. And you can clearly see that as we decrease the amount of nitrate nitrogen, we decrease as well the uptake of potassium, calcium, magnesium, as we saw it before. Look that on the first column, 3:1, the level of potassium, it's around 10.5. And with the same amount of nutrients applied, but just changing the balance between the nitrogen source, if you go to the last column, 1 to 3, you see that from 10.5, we drop to 2. Potassium content in the plant tissue. Same for calcium. We drop from 5.9 on the 3:1, we drop to around 1.8 for 1 to 3. And this is just doing the nitrogen balance. The amount of nutrients applied was the same in all the treatments. The only difference, it was the nitrate ammoniacal nitrogen ratio. So, and this is what you can expect about the balance and the antagonism and synergies between the nutrients. Another point to consider is the temperature at the root zone. This is to exemplify a scientific trial that was conducted in France and presented as well in Switzerland. When we have the temperatures, that numbers 10, 17, 25, and 32, that is the temperature at the root zone, but the temperature is in Celsius degrees, not in Fahrenheit, so that for you in the United States, you need to do the conversion. So this is not Fahrenheit, it's Celsius degrees, but that's the temperature at the root zone. And In one side, the plants was fed only with ammoniacal nitrogen source, and on the other side, only with nitrogen as nitrogen source. And for the temperatures between 10 and 17 Celsius degrees, you see that the plant development, it's more or less the same. At 25 Celsius degrees at the root zone, we can already see some precocity in the plant that was fed with nitrate. But at 32 degrees, you see that the plant that was fed only with ammonium have died. And with 32 degrees, the plant with nitrate is still alive and producing. And why this? Why in higher temperatures, the plant that was fed only with ammonium have died and with nitrate no? That's due the nitrogen cycle inside the plant. That's the reason. When the plant uptake ammoniacal nitrogen, that nitrogen will be converted to amino acids and proteins on the roots. And when the plant uptake nitrate nitrogen, the nitrate nitrogen will be converted to amino acids and proteins in the leaves. And that is the difference, because to do this conversion, plant need energy, need sugars, need carbohydrates. And the carbohydrate sugars are produced due to the photosynthesis process in the leaves. So nitrate nitrogen, to do this conversion in the leaves, is, let's say, is near the factory, near the carbohydrate, the sugars factory, because it's in the leaf. So it's very efficient process. To do the conversion of the ammonium conversion, plants need to send that carbohydrates from the leaves to the roots. And that's a natural process. Plants do that naturally. But when the carbohydrates goes to the roots, the first point, the roots use that carbohydrates for respiration process, keep the roots alive, growing, and then the excess or the extra carbohydrates go to the nitrogen conversion. In higher temperatures, now what's happened is that the respiration in the roots increase due to the higher temperature. As the respiration process increase, plants consume more carbohydrates. That means less carbohydrates available for the nitrogen conversion. And after a while, if the ammonium is not converted to amino acids, the ammonium will be converted in ammoniac. And ammoniac is toxic to the plant and then kill the root and kill the plant. And that's not happened with nitrate. So that's another thing to consider in the nitrogen source, is the temperature at the root zone, especially for areas with higher temperatures. But this is only happens, okay, plant die only with strawberry because it's very sensitive. We never will see a citrus tree dying in the field because this, but we will lose some roots. We can cause some damage on the roots on that. And then even if we have a small damage on the root system, then we are decreasing water and nutrient uptake. And we need to consider that and avoid that because we want to be efficient. Another point is the presence of saline growing conditions. This is a practical effect trial that we conducted in South Africa to evaluate the difference between all the potassium sources in crops that are growing under saline conditions. So what we do, we prepare two different kinds of substrates, river sand with sodium chloride to simulate salinity, increase salinity, and river sand with sodium chloride plus some calcium carbonate to simulate salinity in a higher pH conditions. So we have salinity with neutral pH and salinity with higher pH, alkaline conditions. And then we evaluate same amount of potassium, but apply it as potassium chloride, sulfate, and potassium nitrate, and check the plant development in all of them. So these were the treatments. You can see that for nitrogen, the total amount of nitrogen in the nutrient solution was the same, 262 for all treatments. But the difference is that when you use potassium nitrate as source, you see that around 60% of our nitrogen was in nitrate form, and around 40% of the nitrogen it was in ammoniacal form. The column of sulfur as well, we have another difference, because when you use potassium sulfate, you see that the amount of sulfur is really high in comparison with potassium chloride and with potassium nitrate, especially with potassium nitrate, the lowest amount of sulfur. And the amount of chloride, it was the same for potassium sulfate and nitrate, and of course it was higher with potassium chloride. So that was the balance between the nutrient solution that we compare. And then you can see on the graphics, in sand with neutral pH, just with some sodium chloride, so that means saline condition but neutral pH, that for the first 2 weeks, no significant difference, but after 3 weeks, feeding the plants with these 3 potassium sources, then you can really see the difference, that the potassium nitrate gives the best performance for plant development under saline conditions in comparison with potassium sulfate and potassium chloride. And similar result when you compare the plant development in saline conditions plus higher pH alkaline conditions. Very similar. We see that for the 2 first weeks, almost nothing changed, and from the 3rd week ahead, we see that better performance in potassium nitrate, potassium sulfate, in comparison to potassium sulfate and chloride. So that's the result, and you can see the impact on the potassium sources in plant development. And the last one, for the water use efficiency, now we have a lot of scientific trials that show that the biomass, dry matter content production is higher when you have higher percentage of nitrogen in solution in comparison with ammoniacal nitrogen in solution. As you can see, this graphic, the blue column, it was the dry matter content produced with plant feeded only with ammonium. The orange column, it was the amount of dry matter content produced with nitrate in the nutrient solution, even in 3 different potassium concentrations in the nutrient solutions. So then you can see that the dry matter content, or dry matter production, is higher when we have nitrates in solution in comparison with ammonium. That means efficiency. So to conclude that, if you look to the benefits and the difference between the sources when we apply, we need to consider, for example, that the difference between nitrate nitrogen and ammoniacal nitrogen. Nitrate, it's non-volatile, so no, you don't have losses by volatilization when you use nitrate nitrogen. Is immediately available for plant uptake, no need any kind of transformation. If you apply nitrate, plant will uptake immediately. We have the synergies with the cations. When you have more nitrates, you have more potassium, more calcium, more magnesium absorption. Ammonium toxicity in elevated temperatures, so keep in mind, if you are in an area with higher temperatures, you can have some damage in your root system because the ammonium toxicity. The conversion of amino acids in nitrates occur in the leaf, so it's much more efficient. And all this is a summary of all that benefits that I just mentioned to all of you. So when you're thinking in what source will you apply, think in what is the chemical or mineral composition of the source that you apply. Because sometimes you apply the same amount of nutrients, but in different chemical forms. And that makes all the difference, as we just showed. Here's some beneficial situations about foliar applications that you can do. Sometimes if you have a kind of limit in our root system of the nutrient uptake, foliar applications can also help or supply part of this demand if you have some limitation in our root system or in the uptake of nutrients from the root system. So just some examples, practical example that you can do with foliar applications. This is with Valencia orange, and you can see that when you do applications, 3 applications, with around 20.5 pounds per acre, you spray it, in 3 applications, we increase it, the number of fruits per tree, from 293 to 378. We increase the total soluble solids content, as well as mentioned. That reflected in increasing in the fruit yield and in the gross income, from 9% to around 12%. So this is with 3 foliar applications with potassium nitrate. Another trial conducted that evaluated the effect on the plant resistance of the greening, the HLB. It's a trial conducted by 5 years trial. When you can see on the first picture, 2008, the tree affected by the HLB, the greening effect, and then they start to do the treatments with foliar applications. You can see in 2012 and in 2014. On that time, it was doing 3 applications of potassium nitrate with 22.5 pounds per acre spray in March, June, and September. But in extreme situations, you can do as well a monthly application, really in order to keep the shape of the plant. This is a standard program recommendation that you can use it as foliar. The pre-bloom and post-bloom, this is to really help the plant and increase the cell division process, and the applications during the fruit grow is really to increase size. That applications are important because as higher is the cell division process on that phase, that means higher will be the number of the cells in the fruit and higher will be the fruit size at the end. So that are key moments to do foliar applications in citrus if you want to do it. And that was why I prepared it to all of you. I would like to thank you for all your attention. And as well, you can scan this QR code in order to get some credits that it's allowed it as well. So thanks to all of you.
I just wanted to let everybody know that it's a real easy app. Just go to your CCA or Certified Crop Advisor app and download it. It's free. This screen will come up once you set your password, and you can scan this code, and it'll be available this show as a recorded show, so you can take your time with it.
Thanks, guys.